Bam! Hello there everybody, and welcome back to our next video on how to go from zero to hero in cadence development. And in this video, we're going to be talking about some cadence anti-patterns. So if you go to docs.onflow.org/cadence/anti-patterns, you will see there are some anti-patterns here. Now, what are anti-patterns? Well, anti-patterns are usually things in code that try to work against you or that could be potentially harmful. Now, there are some here that you could sort of go over in your own time, I guess, but I wanted to point out by far the most significant one that you're actually going to see a lot in your code. So if we scroll down a bit, you'll see stuff like events and resources might not be unique, named value fields are preferable. A lot of these are like preference based, so they're not extremely like vulnerable or scary. But the one thing that actually everybody should be aware of in Cadence, and this is so important, is that array or dictionary fields should be private. Now, I want to make if I was on the Flow team, I would make a slight modification to this. It's that array or dictionary fields should be private or access contract or access self. What do I mean? Or access account. What do I mean by that? Well, let's go to the Flow playground. Now, let me write some code, and then we're going to go over why this is an anti-pattern. So if I have a contract called test contract, if I write pub var people, and I have an array of addresses, right? So let's just say this is an array that holds a bunch of addresses in it, or people. And I'm going to initialize this to a array. So self.people equals, let's just put some addresses in there, 0x2, 0x3. Okay? And so it's a very simple contract. Now, remember back to our access control video. What did we learn about public? Well, public, right? So public, so the read scope is anywhere, but the write scope is only within the current scope. So this means that public should only be writable inside of this contract, right? Because this is defined at the most top level, so we should only be able to change it inside the contract. Now, this is true, but only somewhat, and I want to describe that in a bit. So let's go to a transaction, and let's try to do something, right? So inside of our execute, let's say test contract dot people, and we're going to try and change this to a new array. Okay, so let's just say instead of 0x1, 2, and 3, let's say 4, 5, and 6. Now, what do we get? Cannot assign to people, field has public access, consider making it publicly settable. Now, this is what we expect, right? We shouldn't be able to change the array. But there's an anti-pattern, which is what we're going over, where you can change a certain index. So what I mean by this is, let's say we wanted to change the first element of people. We could. Now let's see this. So let's first log test contract.people, and then let's copy this again and do it after we make the change, and let's see what happens. So if we run this transaction, look what happens. It actually changes the state. And so inside our contract, this is now completely changed, and that's not good. So the reason for that is because this is an anti-pattern, and you may ask yourself, well, how do we fix this? Well, we can fix this by making public access contract. Or you can make it, so let's just say things you can do. You can do access contract, access account, or access self. Basically anything that's more limited than public. So let me also just write contract here. And so now what's going to happen is if we redeploy this contract, now we can't, if we were to like refresh this, it's not going to let us do this, right? So field has contract access. We can't even do this now, right? And so it's not going to even let us make this change. Now you may be asking, well, what if I wanted to read this outside of the contract? Well, then what you should do is you should make a function called public function like read people or something that just returns an array of addresses. And inside here, you would say return self.people. And so it's going to return your array of addresses. We can actually go back and we can say log, log test contract dot read people. If we refresh this page, if we run this now, it'll actually print this out. So value has no member read people. It should. I think it's just glitching for some reason. I don't know why. But okay, so I think it's just glitching for some reason. Unless did I spell something wrong? Read people. Maybe I should do this in a script and see what happens. So this returns an array of addresses. Let's go ahead and import our contracts. The playground's so buggy. I wish they would fix it, but you should be able to do this. Dot read people. Oh, return. Okay, execute. What's going on? Oh, did I never redeploy this? Oh, well, there you go. The Cadence God has forgotten once again. Okay, so there we go. So now if I forgot to redeploy the contract, silly me. Okay, so if we then log test contract.read people, you'll see it returns the array, and we can't change anything about this, right? Because if we were to, for example, store this in a variable, right, like let thing equals this, and we just store this in a variable, if we were to change thing and say like thing at 0 equals 0x6, the thing is just a copy, right? So the thing is just a copy of the array of addresses. This returns a copy, so it's not going to actually change the self.people. So this is really important, and I also want to say that this is also a thing for dictionaries. So if we were to make this address bool, for example, and we were to say self.people is 0x1 true, 0x2 false, something like this, right? And we were to do let's just change this to like address maps to boolean, like so. And we were to redeploy, and let's just make this public so I can show you that it just changes. Let's redeploy this contract. Let's go back to our transaction, and let's do the same thing we were doing earlier. So let's log test contract.people. Let's do this again down here, and let's say people at 0 equals false. Let's refresh this page. Test contract.people at 0 equals false. Or sorry, at 0x1 because it's an address to bool. Remember, we initialized it to true, but let's watch it change to false. So boom, it goes from true to false. And so this is also a problem with dictionaries. And so the way to fix that is to change this to like access, contract, account, or self. So this is an extremely important vulnerability that you should be aware of in Cadence code. And this doesn't just apply to, this, for example, this is the same thing if you have like public resource test, and you inside of here you have like, for example, a public var. Let's just also do like thingies, and this is just an array of strings. And we were to initialize this and say self.thingies equals just an empty array. You have to be extremely careful too, because if you were ever to return for a reference to this, for example, you could change thingies even though it's public access and should only be changed within this resource. Really, you would be able to do that same sort of thing if you return. So if we did, for example, public function get test, and we returned for some reason an array of a reference to the test resource, it would actually allow you to change this even though you shouldn't be able to. So make sure you're always aware, always aware that public, or of course public set's a problem, right? Because you can change that anywhere, but be really careful that public access control, or that arrays or dictionaries with the public access modifier are changeable outside the contract. So always make sure that they are either access contract, account, or self. And I would even argue that if you ever even have any dictionary or any array, it should always be one of these three, and you should never have a public array or dictionary. It's bad practice. So I hope this helped, and I'll see you in the next one.